So this video is going to be on surface area of 3D figures. We're going to focus on prisms, pyramids, cylinders, spheres, and cones. So basically all the 3D shapes that we can. So just to start off here, remember that two-dimensional shapes have this measurement known as area, which is basically how much the shape covers up or how much space is inside the boundaries of the object, right? So if I draw a rectangle like this, and I ask you to find the area is basically how much space is inside here, right? It's that much green um, stuff inside the object, essentially. Well, the surface area is basically the 3D analogy of area. So the surface area is the sum of all the areas of the faces. I should say faces and bases, because technically the base is also a face of the polyhedron. But we'll say faces and bases of a polyhedron. Remember, a polyhedron is just a fancy way of saying a three-dimensional figure for the most part. So one way to think about this is the amount of skin on a 3D object. So if you think about, a box or a pyramid or something like that and covering it with skin, that's how much skin you would need as a surface area. Or most people think of it as the amount of wrapping paper it would take to wrap an object completely with no overlapping and no gaps. So if you think about, again, a present in the shape of a box, like a shoebox or something, how much wrapping paper would it take to wrap all the way around that box, all the faces covered with wrapping paper with no overlap? That's the surface area of that object, essentially. And there are formulas to do this in your book. It's on page 78. But instead of using the formulas for most prisms, at least, and pyramids, it's easier just to break it down into the individual faces, find the area of the individual faces, and just like it says up here, just take the sum of all those areas and put them together. So that's kind of the route we're going to be taking here. But there are formulas if you want to look at them in your book. And again, you can let me know if you want to go more into detail about them. But we're going to focus on kind of the breakdown method of get all the areas, put them together, and then go along with the problem there. So again, when I say the area of all the faces and bases, I'm talking about like saying this piece here, this front rectangle, plus this side rectangle, plus this top rectangle, plus the back rectangle, plus the left rectangle, plus the bottom rectangle. So I'm adding up all the different pieces of the object and putting them together, and that's what I get for the surface area. Now, for non-polyhedron, which is basically stuff with a curved shape to it, which are cylinders, cones, and spheres, we actually have specific formulas for those that we need to remember because these don't have an easy way of doing them without the formulas because they have those curved pieces to them. So for a cylinder, you have this formula here, 2 pi rh plus 2 pi r squared. And basically what this is, remember, a cylinder has a circle on top, which has a radius, and it has a height, which is the distance between the two circles. And the reason this formula comes into being here is that this piece right here, 2 pi r squared, that takes care of the top and bottom circle essentially. So that's, again, pi r squared is the area of a circle, 2 pi r squared because we have two circles, one on top and one on bottom, and they're both identical. So we don't need to do two separate circles, we just need to do one circle and then double it, which is why, again, that 2 is there. So we have pi r squared for one circle times 2 because we have a top and a bottom. This right here basically takes care of the tube portion of the cylinder. That's that shape that wraps around there. Remember the last video we had a net of the cylinder, which looked like this. So we had a net here, and then we had a circle on top and a circle on bottom, and that's how we got the net of the cylinder. That's what you get if you like cut a cylinder up into its individual pieces. And it so happens that this right here, 2 pi rh, is the area of this rectangle essentially, because it has a height of h. That's the height. And the base of this rectangle is actually the circumference of the top circle, which is 2 pi r. That's the area of that's the formula for circumference of a circle. So if you do base 2 pi r times height h, you get 2 pi rh. So if you want to know where these numbers are coming from, they're not just random. They're coming from the fact that if I cut a cylinder up, these are the two shapes I get. I get two circles, so 2 pi r squared, and I get a rectangle who has a height of h, which is the height of the cylinder, and it has a base of 2 pi r, which is the circumference of the circles. And so it's a kind of a long formula compared to some of the other ones we've had, but it has a certain flow to it, right? 2 pi rh, 2 pi r squared. So as long as you kind of remember that flow there, should be all right. And again, first part takes care of the tube portion. Second part takes care of the top and bottom circles together. For a cone, it's kind of similar, except that since we only have one circle on bottom, we have pi r squared, not 2 pi r squared. And then this pi r L takes care of this curved portion on top, the actual conal portion of the cone. And the L there is the slant height. So that's this height right here. Basically, if you were to stand at the top of the cone and slide down, that L is the distance you would slide. So it's not the height like this. It's not the straight up and down height. That's H. And notice here again, this formula doesn't use H. It uses the slant height, not the actual height. Sometimes you might have to do Pythagorean theorem to get the slant height, because remember you have kind of a right triangle here. If you look at these lines, you have the radius here. That's the R, H, and L. They kind of make this little right triangle. So again, Pythagorean theorem might come into play, but we only want L for the surface area of a cone. And once again, this part here takes care of the bottom circle. This part here takes care of that conal portion, which is that V-cut circle we talked about in the last video, where you have that circular piece on top that has that V cut out of it, so it makes that conal aspect to it. And then for a sphere, there's really no great way to kind of say where this comes from. There's actually kind of a bit of a procedure to it and a proof to it. But remember, a sphere has a radius. It doesn't have a height or a base or anything like that. It just has a radius and a diameter, I guess. But the way we get the surface area is just 4 pi r squared. And the way you remember this is it basically takes 4 circles to cover a sphere. So pi r squared is the area of a circle. If you take 4 of them and you can arrange them together, then you get a sphere. So a sphere is basically 4 circles, so 4 pi r squared. 2 circles to make the top dome, 2 circles to make the bottom dome, 4 circles total. So these formulas we actually have to know and where they apply to, but for the other shapes that aren't curved, we can just break it down into individual faces. So there's actually 2 types of surface area. Total surface area is the one that we deal with the most. So if they don't tell you otherwise, assume it's the total surface area. So they don't say, you're assuming you're working with total. That's just basically the combined surface area of everything altogether. So for instance, if I take my little shape down here and put it back up here, so if I clone this and put it up here, so my total surface area is adding up all the different pieces. So add up this side, or this face, the back face, the front face, the top face, and the bottom face. Add up all the different faces together. So this is, in words here, this is top plus bottom plus left plus right plus front plus back. Every side added together. Whereas lateral surface area is just the combined faces, or in this case, the sides of an object, essentially. So basically, you exclude the base. So if you picture a box, all we do is we take left plus right plus front plus back. So in this case, left plus right plus front plus back. We don't take the top and the bottom because those are the bases of my object, and I don't want to include those. So again, think about like a cereal box. If the lateral surface area of a cereal box is everything on the front, everything on the back, everything on the left, everything on the right, but if you don't count the top rectangle where you open the cereal box and the bottom rectangle which is directly below that, if you don't count those and you just take all the other ones along the side, that's the lateral surface area. So lateral surface area is the sides of an object, whereas total surface area is the sides and bases of an object. Normally, again, we're only talking about total, but every now and then lateral comes up, and so it's a little bit less work because you don't have to worry about the top and bottom base anymore. But just know when it does come up, that's what it means there. And for pyramids, just as an aside here, actually we'll get to that when we get to the pyramids. So let me save that for later. So we'll put that on pause for a minute. So let's do some basic problems here. So let me divide these down the middle just so we have a clear workspace. So find the total surface area, or it says find the surface area. Again, we're going to assume it's total because they didn't tell us otherwise. So what we do here is we break this down to the individual faces, kind of like we did in the last video with the nets. So I have a front square here that's like 3 by 3 square. So I'm going to draw that here. You have a 3 by 3 square on front. That's my front side. I'll put F. My back is also a 3 by 3 square. So 3 by 3, that's my back side. We'll call this my like upper right side. That's kind of like here, 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 here. That looks to be an 8 by 3 rectangle, so I'll write that down here. So this is 8 by 3, and we'll call that my right side. And my left side then is pretty much the same, correct? So here, 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 here. So again, it's also 8 by 3. So another 8 by 3 for my left side. So that's my left side. Actually, we'll just put capital L there. Ah, 8 by 3, and that's left. Let me make that 8 a little bit better. There we go. And then we have top and bottom, right? Or I guess, again, this is kind of on its side, so it's kind of hard to tell top and bottom. But we basically have this piece right here, this kind of top looking piece, and we have this bottom looking piece right here, which again are both 8 by 3 because the base is a square, so we're going to have a lot of repeats here. So 8 by 3 for top, and then 8 by 3 for bottom. And so to get my surface area, let me tone down the thickness here. To get my surface area, all I'm going to do is find the area of all these shapes and add them together. So for a square, base times height, area is 9. Base times height, area is 9. Here, 8 times 3 is 24. Here is 24. There is 24. And there is 24. So I found the area of the front, the back, the right, the left, the top, and the bottom, all one by one by one. And now you just add them all together. So you add them all together. Add, 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 add. So we're going to do 9 plus 9 plus 24 plus 24 plus 24 plus 24, and we get a total surface area of 114. So make that 1114 a little bit better. There we go. So again, we didn't necessarily use any fancy formulas here. We just broke it down into face by face by face. In this case, we had a lot of repeats because if you have a square, like 3 by 3 by 3 by 3, if you have a square, you tend to have a lot of repeats because, again, you have a square, so a lot of sides are equal. If you have a more traditional rectangular prism like over here, then you don't have as many repeats. So if we try this one out here, again, let's go ahead and focus on the front and back first. So my front side would be this right here. That's my front. And that looks to be 9 by 8, which is going this way. So 9 by 8. So my front would be a rectangle, be 9 by 8. And then my back side is also going to be the same way, same numbers at least. So back here, there is also a 9 going up and down this way, by 8 going left and right that way. So another 9 by 8. And then, get rid of this there. We have my left and my right? So let's do this one right here. So that right there, and then this piece right here. And so we have this one, which is 9 by 2, and this is also 9 by 2, because again, they're going along the same edges there. So my right side is a fairly skinny rectangle, 9 by 2. My left side, I keep doing my cursive L. Whoops, I didn't want to erase all that. 9 by 2. And then my left side is also 9 by 2. And then I have my top and bottom, right? So I have my top piece, which is here. And then my bottom piece, which is down here. And again, same deal. 2 by 8, 2 by 8. So here we have 2 by 8 for my bottom. And then here for top, we also have a 2 by 8 or an 8 by 2, depending on how you want to say it. And so I just, again, figured out the areas of all the shapes and put them together. So 9 times 8, that's going to be 72 for both of these. 9 times 2 is 18 for both of these. And then 8 times 2 is 16 for both of these. Again, base times height to find the area of all the shapes. And so then you just add them together. So 72 plus 72 plus 18 plus 18 plus 16 plus 16, and we get 212. And this would be kilometers squared if I'm labeling it correctly. So again, basically you take one big problem and break it down into 6 small problems. Front, back, left, right, bottom, top. and just find the areas individually and combine them all together. Now, these are both rectangular prisms. You can also do any type of prism you want as long as you know how to find the area of all the shapes involved. So triangular prisms and rectangular prisms are by far the most common, but as long as it's a regular polygon, we can do pentagonal, hexagonal, and trapezoidal prisms as well. Basically, your front, your back, or your top and your bottom, whatever, will be your two bases, and then everything else is going to be a rectangle. Now, for rectangular prisms, because they're nice and rectangular, there's actually a shortcut. If you noticed here, we always had repeats, right? Front and back were always the same. Right and left were always the same. Bottom and top were always the same. So to kind of shortcut this procedure just for rectangular prisms, again, I want to emphasize that this is only for rectangular prisms, this shortcut here. You can do the following kind of procedure, is instead of finding all 6, just find 3, and then double your answer. So in this case here, if we look at this, let's do this side right here. This is a 9 by 6 side. We'll call that my front side because it's kind of facing towards me there. So 6 by 9, this is my front. So I go there. That is a 6 by 9. And then if I do the bottom, so my bottom piece right here, that looks to be a 6 by what looks like to be 10. So 10 this way, 6 that way. So my bottom is 10 by 6. And then I'll take that my right side here, this side over here. That looks to be 9 going this way by 10 going that way. So we'll do a little 9 by 10 for my right side. And so instead of finding all the other ones, as long as I find these, front, because that corresponds to back as well, bottom, because that corresponds to top, and right, because that's going to be the same as the left, all I need to do is figure out the areas of each of these shapes here. So 9 times 6 in this case is going to be 54. 10 times 6 is 60. 10 times 9 is 90. I can then add these together. So 54 plus 60 plus 90. And we get 204. And then I'm going to double it because what I essentially have here is I have half the rectangle. I have the front, the back, the bottom, and the right. So in order to get the back, the top, and the left, I would just take this and double because those are all going to be the same numbers anyway and get 408. So instead of finding all 6, all I did was find one of each. So I found the front, I found the right, and I found the bottom. And I just add those together and then doubled it at the end to make sure I account for the ones that I just didn't get through my adding. So again, this only works for rectangular prisms, but it does shorten up your work a little bit by cutting it in half essentially. So instead of finding all 6 shapes, you just find the 3 key ones, front, bottom, right, or it could be back, top, left, as long as you find, again, one of each pair, and then add them together and multiply by 2 at the end to get the entire prism. If I wanted just the lateral surface area, by the way, for this problem, if I wanted just the lateral surface area, what I would do is I would find the areas of just this piece right here, find that area, which is 9 by 6, this piece right here, which is 10 by 9, and then I would also find the areas of their counterparts. So I'd find the area of this piece over here and back, and then I would also find the area of this piece over here and kind of the upper back there. And I would add all those together. So basically, I wouldn't find the 10 by 6 on top or the 10 by 6 on bottom because, again, for lateral surface area, I just want the sides of the object, not the actual top and bottom pieces. And word problems, they tend to not give you a picture, obviously, but as long as they give you the measurements, you're actually good. For a rectangular prism, at least, you don't really need a picture. For triangular prisms, it's really helpful to have a picture, but for rectangular prisms, you don't because, again, I just showed you the shortcut that you have there. So a shipping container measures 20 by 8 by 10 and needs to be painted on all sides. How much paint is required? So first of all, in case you're not used to labeling, 20 by 8 by 10 is kind of like saying that this here is a 6 by 10 by 9. So 6 by 10 by 9, you're just giving me all 3 measurements of the shape essentially, the length, the width, and the height or the depth of the object. So just in case you weren't used to how that's shown to you here. So 6 by 10 by 9 means these numbers here, and so 20 by 8 by 10 simply means those numbers on their own prism. Now, again, if you want to draw a picture, you can, and I encourage you to do so if this is still a little bit fresh for you. But what you could do here is, because you don't really need the picture, all you need is the numbers, you could do this. This is another kind of like a little trick just for rectangular prisms and for word problems. You basically pair each combo up once. So for example, I would do 20 times 8, so I pair the 8 and the 20. 20 times 10, so I pair the 20 and the 10. And then 8 times 10. So I pair the 8 and the 10. So each number gets paired up with the others just once. This gets you 160. This gets you 200. And this gets you 80. Then you're going to add them together. So add all those together. So 160 plus 200 plus 80. And you get 440. And then, as we said before, you're going to double it. And you get 880. That'd be feet squared. So 880 square feet of paint is required to paint this shipping container. Now again, why does this work? Well, basically what you're doing is you're doing this here. You're finding the front, the bottom, and the right. It's just that instead of having the picture, you know that each pair is going to happen once. And 9 and 6 get paired together. 9 and 10 get paired together. 6 and 10 get paired together. So every number gets paired with the other ones at least once. You find the area, and then you just add and multiply by 2. Same thing here, it's just that I didn't have a picture to guide me, but as long as I have the numbers down here, I can follow that trick. Again, only for rectangular prisms though. Triangular prisms you always have to have the picture for, and we'll go over one of those here in just a second. But for rectangular prisms, you have that trick of just combining numbers a pair at a time. Now, some prism problems will require you not to necessarily shade every piece of it. So for example, in this case here, we have a cake to be coated with frosting except for the bottom. So you're not obviously going to frost the bottom of the cake because it's going to be sitting on the plate. So it says it has a 12 by 6 inch rectangular base and it is 2 inches high. So that means that this 12 by 6, that's what's going to be sitting on the bottom. So this 12 by 6 here, if it's the base, that means 12 by 6 is both the front, or sorry, both the top and the bottom. So that means I'm going to not include one of these in here. So if I make a diagram here, so we have front, we have right, and we have back. Or sorry, not back, we have top. So front, right, top, or you can do front, left, bottom, or you can do back, right, top. Again, as long as you have one of the pairs, it's fine. So front and back are a pair, left and right are a pair, and then top and bottom are a pair. So as long as you have one of each pair, you're good for using our little trick here. So we already said here that 12 by 6, that's going to be the top and bottom, so I'll put that right here, 12 by 6, because anytime something's the base, that usually means it's the top or the bottom of the prism there. It doesn't always have to be, but you can assume it is, and your problem will work out just fine. So how do we get the right and the front? Well, they're obviously not going to be 12 by 6, but look at this little note here, 2 inches high, which means both of these are going to be multiplied by 2, because the height is part of the front and the right sides. If you look over here, back at their ones here, the height of, if I go back here, the height of this prism, if I erase this, here we go, the height of this prism, which was 9, this side right here, that was always part of the left and the right and the front and the back of the object. So 9 was in the front and the back, and 9 was in the left and the right. It wasn't in the top and the bottom because, again, the top and the bottom is not worried about the height. The top and the bottom are just the flat pieces on the top and bottom of the object. So the height is always part of your front, back, right, left combos. So that means that both of these are going to be multiplied by 2, which means that one of them is going to have a 12, and one of them is going to have a 6. Now, lucky for us, it actually doesn't matter which one you put the 12 and the 6 at, because like I said, each number needs to get paired with the other ones at least once, right? So 12 and 2, 12 and 6, 6 and 2. Every pair happens once. 12 and 2 get paired, 12 and 6 get paired, 6 and 2 get paired once each. So it doesn't matter whether you put the 6 up here and the 12 down here, or the 12 down here and the 6 up there. It's going to give you the same answer anyway. Again, we're just combining our numbers here. So 12 by 6 as a base, and then a height of 2 essentially means 12 by 6 by 2 is another way of saying this object here. So if you want to rewrite your problem with the triple notation here first, that way you can see what numbers pair up, you can do that as well. So here I would do this. Now, because I'm excluding the bottom, I'm going to have to modify my approach a little bit. So 12 times 2 is 24, 6 times 2 is 12, and then 12 times 6 is 72. Now, normally I would add and then multiply by 2, but I'm not going to multiply by, well, actually, you know what? Let me do it this way. This might make it easier sense. Let me actually do that here real quick. So I'm going to add, and then some of you might see where this is going here, but let me just go through it. So 24 plus 12 plus 72. Let's see where this goes. So that's 108 times by 2, and that gets me 216 inches squared. Now that's if I frosted every side. But I want to frost every side except the bottom. So what I'm going to do is I'm going to take this 216, and I'm going to subtract the bottom slice, the area of the bottom slice, which again here is 12 by 6, because that's the area of the top and the bottom, respectively. 12 by 6 for the top, 12 by 6 for the bottom. So subtract 72, because again, that's what 12 by 6 is. So minus 72, and we get, 216 minus 72, and we get 144. So this would be the actual amount of frosting I would need to frost this cake, because I'm not going to frost the bottom slice there. So this might be the easier way of doing it rather than trying to subtract at the beginning here. Is find the surface area like you normally do, get all three sides, add them together, double it, and then subtract off the piece that you don't need or the pieces that you don't need. Sometimes you're not going to use two of the faces. Just be aware of what sides are your bases, because they'll usually tell you that, or they'll give you a picture to show that. And remember that your bases are usually representing your top and bottom section. So if you want to always think of your bases as your top and your bottom of a rectangular prism, then go ahead and do it that. Now again, triangular prisms are a little bit different. So this has all been rectangular prisms so far, which is great. But for the other prisms like triangular prisms, pentagonal prisms, octagonal prisms, those you don't get to choose. So in a triangular prism, the bases have to be the triangles, because that's what it's called. For a pentagonal prism, the bases have to be the pentagons, because again, that's what it's called, a pentagonal prism, not some other type of prism. But for a rectangular prism, because all the faces in a rectangular prism are rectangles, it really doesn't matter which one you call the base. So if I say this is my rectangular prism, technically any side here could be my base, which is why we just kind of usually refer to it as the top and the bottom, because that's easier to kind of have something to hold on to and be certain about every time. So speaking of triangular prisms, if you have a triangular prism like this, again, two triangles, one on bottom in this case and one on top, which is good for us, then you have to go back to the original method of just breaking it down face by face by face. So if I have top and bottom, these are both triangles, right? So top is this triangle right here. Ugh, I can't trace. So top is that triangle there, and then the bottom is this triangle down here. Now, the bases should be identical. So really, once you find the top, you've already found the bottom as well, which again is good for us. So let's kind of draw this out here. So my top triangle, it's a right triangle, which is good. Right angle right there. This right angle right here. That's in the corner. That's going to be 8 by 6 by 10. So 8 by 6 by 10. And then my bottom triangle is going to be the exact same, because remember, top and bottom should always be the same in any prism, even triangular prisms. Right angle there. So to get the well, let me get all the other sides first. So we have front and back. Actually, we really don't have a front and back here. We have a front, we could say, but we really don't have a back. We have more of a sort of left and right. So let me do it this way. Let me erase these green lines here. Let me actually just label them. So I'll call this rectangle here. That'd be rectangle 1. Try that again. So this rectangle here, I'm going to call that rectangle 1. Then this back rectangle here, I'm going to call rectangle 2. And this one way, way, way back there, so all the way in the very back, behind the object, I'm going to call rectangle 3. Again, something you might want to do when you're doing yours is to kind of outline or trace or highlight them. That way you have your clear rectangles drawn out for you. So for rectangle 1, that is a 6 by 3 rectangle. So 6 going this way, and then 3 going this way. So it's going to be a 6 by 3. For my rectangle 2, that's going to be an 8 going this way, and then a 3 going up and down again. So that's going to be a 8 by 3. And then for my rectangle 3 way in the back here, that's going to be 10 this way, and then 3 this way. So that'd be my rectangle 3 would be a 10 by 3. Now, if you notice here, in a triangular prism, there's something that happens. All 3 rectangles should have one number shared between them. In this case, 3, 3, and 3. So the height of a triangular prism, essentially, is going to be shared between all 3 rectangles. So if you're doing a triangular prism problem and there's not a number shared between all 3 of your rectangles, then you did something wrong. So go back and check your numbers there. But all 3 rectangles in a triangular prism should have only well, I shouldn't say only. It should have at least one number repeat because you have a very nice and kind of squarish, almost rectangular, triangular prism. But they should all share at least one common number for all your rectangles. So go ahead and find the areas then. So 6 by 3, that's going to be 18. 10 by 3 is going to be 30. And then 8 by 3 is going to be 24. And then for triangles, remember, triangle is base times height divided by 2. So in this case, my base is 6 and my height is 8. Remember, I don't use the slanted section for an area problem. So it'd be 8 times 6 divided by 2, which will give you 24. And then the bottom is also going to be the same because it's the exact same triangle. So you add them together here. 24 plus 24 plus 18 plus 24 plus 30. And we get 120. So it'd be 120 miles squared as my answer. Again, this involves breaking it down into each individual face and then adding together. Triangular prisms are always going to be broken down into 2 triangles and 3 rectangles. So if you have a triangular prism, the way you solve the area is figure out what your 2 triangles are. They should be the exact same. Figure out what your 3 rectangles are. Your 3 rectangles may be the same if they're nice and square, but usually your 3 rectangles will have only one number in common, which in this case, in our case, was the 3. So again, use that to help guide you on whether you're on the right track or not. If you're drawing your faces and you see that all 3 of your rectangles, they all have different numbers, that means you missed something there. They should all share, between the 3 of them, they should all share at least one number between them. So for pyramids then, how do we do pyramids? Well, luckily pyramids are actually quite a bit easier. The pyramids that we're going to be working with are usually regular polygonal based, which means that the base is a regular polygon, like a square or an equilateral triangle. And what you do is you basically break this down the same way you do a prism. You have your square base here, right? 10 by 10 by 10 by 10, because all these sides are marked congruent. So 10 by 10, which we know that that area is 100. We can just do that right off the bat. And then we have these triangle pieces. So these triangle pieces here, let me do this in blue. This triangle piece here, that is one of my faces of this pyramid here. Okay? And then I have another one in front, I have another one on the side, and I have another one in back. So I have 4 triangles total. Those make up my lateral surface area. So if you add up the area of all the triangles, that's what's the lateral surface area of a pyramid. If you include the bottom shape, that's the total surface area. And we're trying to find the total surface area here. So if I draw out one of those triangles here, it says that the height of this triangle is 25 feet. So I'll put a little dotted line here. Dot, dot, dot. And we'll say that that's 25. And the base is the same length as the side of the square, right? Because if this is 10 all the way around, that means this base right here is also 10 because it's part of the square and all the sides in the square are the same. So that bottom base there is 10. So the area of this triangle is, once again, base times height divided by 2. So if we do 25 times 10 divided by 2, we get, 250 divided by 2, we get 125. Now, normally what we would do, like for a rectangular prism or a triangular prism, is we would find every single face here, right? But if you notice, if it's a regular polygon on bottom, like a square, all the triangles are going to be the exact same. So this front triangle right here is also going to have a base of 10 and a height of 25 feet. And this side over here, this triangle on this side, is going to be the exact same. It's going to have a base of 10, and the height is also going to be 25 feet because it's the exact same triangle just on the other side. So instead of finding each one individually, what I'm going to do here is simply multiply this by 4, because I'm going to have 4 triangles, left, right, front, and back, one for each side of my base. So I'm going to take 125 times 4. I'm going to get 500. This is what's called the lateral surface area again. So this is my lateral surface area of a pyramid. It's just the triangles added together. So if you want the lateral surface area of a pyramid, take all the triangle areas, add them together. That's your lateral area. The total surface area is the triangles plus the base shape. Make those zeros nice. Which in this case gives me 600 square feet. So again, for a pyramid, all you do is you break it down into its base shape, which is the bottom usually, or the top if it's upside down. And then it has a certain number of triangles. It has one triangle for each side of its base. So in this case, I have a square base. Square has 4 sides, so it has 4 triangles. And if it's a regular polygon, which most of the pyramids we're going to look at are, that means that all the triangles are the exact same height or the exact same base. So all you really need to do is find one of the triangles and then multiply it by however many triangles there are in that prism. And again, it's a lot easier than a prism, hopefully, because you only have 2 shapes to deal with, the base shape and the triangles. And you should have between 3 and 4 triangles usually. If you have like a pentagonal or hexagonal pyramid or pyramid, sorry, get my words confused here. If you have a hexagonal or pentagonal pyramid, then obviously you're going to have 5 or 6 triangles. But usually the pyramids we're going to be looking at are triangular pyramids and square pyramids. So usually between 3 and 4 triangles at the most. But again, base area, get your number. Triangle area, get your number. Times it by the number of sides. So again, 4 sides here, so times by 4, and then add them together. And then for the non-polyhedron. So remember, for the non-polyhedron, we have to go back to our formulas. So for this cylinder here, if you don't remember, the formula for the cylinder is 2 pi rh plus 2 pi r squared. Yes, you have to remember the formula, but because there's no, we really have to break this down or match things up, this actually can be quite a fair bit easier, because as long as you know the formula, you're done. You just basically plug in your numbers and go. So in this case, my height is 8, my r is 9, so just go ahead and plug them in. So 2 pi times 8, whoops, sorry, r, which is 9. So 2 pi r, which is 9, times h, which is 8, plus 2 pi and then r squared, which would be 9 squared. So in my calculator, I'm just going to go ahead and do that. So 2 times pi times 9 times 8, put that in parentheses, plus 2 times pi times 9 squared is 81, so I'll put 81 there. And you get 961.327. So 961.327. Now, if they wanted this in terms of pi, so say they said, write your exact answer in terms of pi, do not round, what you would do is you would find this piece first without using pi. So this right here, what I would do is I would do 2 times, not pi, but 8 times 9, or 9 times 8, doesn't matter. I get 144, so this would be 144 pi, plus, and then I would do this piece right here, once again, not including the pi. So 2 times 9 squared, which is 81. I get 162 pi. And then I would add these together, once again, ignoring pi. So plus 144. And I'd get 306 pi as my answer. So this answer right here and this answer right here mean the exact same thing. Because in my calculator, if I type in 306 times pi, whoops, times pi, I get what I got on top there. So they're the same answer, it's just that this one has a pi in it, and this one has the pi actually multiplied into it to get the decimal. So if they say write their answer in terms of just pi, that means that you basically want to go through this entire operation, but just keep the pi on the end here until the very end when you just slap it right at the end of your number. That way this looks a little bit nicer because you don't have a decimal involved. You just have a whole number times pi. It's a little bit easier to kind of read and think about and work with essentially. But they're both correct. So if they say write their answer in terms of pi though, this is the way they want you to do it. First piece, second piece, add together, and just keep the pi along for the ride. Skipping a little bit, let's go ahead and do the cone first before I get to the sphere. So for a cone, remember the formula is, if we go back here, come on, there it is. So pi RL plus pi R squared. So we go here, pi RL plus pi R squared. And you notice, unlike a cylinder, there's no 2 here. So it's not 2 pi r, it's just pi RL, pi r squared. So don't try throwing a 2 in here when there's not. The reason that there are 2 right here is because it has 2 circles. And the reason it's a 2 here is because, again, that rectangle has a circumference for its base, essentially. But there's no 2 involved in the cone. So in this case here, all we do is we do pi times 3 times 11.4 plus pi times 3 squared. Again, r goes in for 3, 3 goes in for r, 11.4 goes in for L. So if I want to write this in terms of pi, I would do 3 times 11.4, and I get 34.2 pi. And then here I'd get 9 pi, because 3 squared is 9. And then I would add these together, and I get 43.2 pi. And that would be my answer in terms of pi. If I want the answer as a decimal, well, as a decimal without pi, essentially, then I would just multiply it in here and get 135.7. That's 6 around the 1 up to a 2. So 135.72. So again, both these answers are the exact same value. This is in terms of pi. This is just the answer as a decimal. Right? This is what they would often refer to as the exact answer because there's no approximation. You're leaving the pi in there to show that there's a pi, whereas this is an approximate answer because you're rounding, because you have a pi involved, the number goes on forever, and that sort of thing. So if they ask for the exact answer, that means leave it with a pi. If they just ask for the answer, you can leave it without the pi and put the decimal. And then for a sphere, probably the easiest one of the bunch, that is just 4 pi r squared. So 4 pi. Now in this case, we want r squared, so it wouldn't be 18, it'd be 9 squared. Because again, 18 is the entire length. I just want this piece right here, which would be half of that, which is 9. So once again, if I want my answer in terms of pi, or the exact answer, it'd be 4 times 9 squared, which is 81. So it'd be 324 pi. That's the exact answer. The answer as a decimal would simply be taking that times the pi itself, and I get 1017.88. So 1017.88. Again, exact rounded answer because the 6 rounds the 7 up to an 8, so that's a rounded answer there, whereas this is an exact answer because I didn't have to round because I just left the pi in there. And again, these will all be in square units. This would be in yards squared, this would be in meters squared, and this would be in inches squared because it is an area measurement. So for these curved non-polyhedron pieces, you do have to use the formulas. But for the other ones, again, for rectangular and triangular prisms, it's just a matter of breaking it down to the individual faces. And word problems, again, look at your measurements and use that to guide you. So if you have a rectangular prism word problem, write down what your measurements are. There are usually 3 of them. And then remember, each pair happens once. So 12 and 6 happens once, 12 and 2 happens once, 6 and 2 happens once, and then you add and double. And then if you need to take off a piece, you take it off at the end. Whereas for triangular prisms, again, you just draw it out piece by piece by piece, and then add them all together to get your answer in the end here. So triangular prisms, you don't have a shortcut, unfortunately. It's just find all the pieces, add them together, and then there's your answer. Again, this takes a little bit getting used to, which is why you practice. Hopefully this video helped you out. Have a good day.